So in a rough sort of sense, capital F is the mirror image of f 2 to the minus x was the mirror of 2 to the x, and 4 to the minus x was the mirror of 4 to the x. All right. Is f of x a function of x? Is f a function of x?
Sure. Yeah, 100%.
Why do you say that?
The vertical test.
The vertical line test? What about all of these things?
Yeah, they all pass it.
All the big
all
F,
the,
little
all the
f,
individual lines
big G, little g? Okay. What about the inverses?
Heck no.
Yes.
Why?
Like if it's the same inverse of the same line.
Oh, yes. It's horizontal.
Look at Carl. Look at Kira's gesture. What is she indicating?
Horizontal line test.
Horizontal line test. What does horizontal line test tell us?
If it has an inverse.
Oh, is that what you're asking?
Yes.
Oh, I was confused about my. Sorry.
So give me a counter example. What's a function that fails either the vertical line test or the horizontal line test? Kira.
F of x equals x squared.
F of x equals x squared. Looks like what?
Ain't got
Parabola.
No inverse.
And it has no inverse
Inversely.
because it fails the
Vertical line test.
horizontal line test. Is this f of x a function of x?
Mm-hmm.
Yeah. it
Why?
is, because it passes the horizontal line test.
Say it again.
Vertical.
Up and down line test.
Yeah, it passes the vertical line test. Give me an example of a function or a graph that fails the vertical line test.
Oh, the
X squared minus.
absolute value of y equals x. Cause doesn't it go like this?
Okay, absolute value y equals x. Does it pass the vertical line test?
It has an inverse.
It doesn't. But does it have an inverse?
Yes.
Because it passes the horizontal line test, right?
Mm-hmm.
Give me an example of a function or a graph that fails both the vertical and the horizontal line test.
Piecewise function. Maybe.
Think of a shape that I could draw.
Oh, a circle.
S.
We have not covered conics yet, and I don't know how much we're going to actually do of it. But do you know what the it's not a function, but do you know what the equation of this graph is? Like
What
if
is
this
it?
is
Wait,
this is
can
R.
I take a guess?
Yes,
Isn't it like R or F?
Carlo, go.
No, bad guess. No, I can't do this. I'm sorry.
This is actually x squared plus y squared equals r squared,
What?
and this y is not a function of x and x is not a function of y. It fails both the horizontal line and vertical line tests. Right. Kira,
Are we behind?
on what?
On just like general, like getting through material.
I mean,
Both sections.
no, both sections are pretty much on par with each other.
No. I mean, in both sections.
And just in life,
No, are we just behind like
Like
last
your
year's class?
year's
I know
class?
was like way ahead, but so if if they were way ahead, are we way behind?
so here's the amazing thing about this school.
Yeah.
There is no expectation of a finish line.
Okay.
So me rushing to quote unquote on paper be on par with last year does absolutely nothing for anyone.
How much are we behind from them though?
I wanna know.
Why does that question even help it? What I'm saying
I
is
just wanna know.
the pace that we go,
Face
that most people are able to
Okay, we're
absorb the
wondering,
material and progress
We're
is
wondering
perfectly
because-
I
fine.
wanna know how bad we are.
we're wondering because at their accelerated rate, they learned more information and it prepared them for next year. So we're wondering how prepared we are for next year at our
So-
pace.
So there is that idea of the amount that we get through, quote unquote, prepares you for what you're going to do next year, but that is not the case.
But
You
math
could
builds in-
imagine that for me to deliver you to Miss Prandtl or Miss Pelton or Mr. Lebo in their pre-calc classes that we have to cover a certain amount of material. That's not the case.
Okay.
So every year is different. Every teacher rolls with whatever you have. If you notice, some people came from a combined Algebra 1 and geometry, and some people came from Algebra 1 and then geometry. Some people remembered Algebra 1 great. Some people remembered Algebra 1 horrible. And so what do? We just sort of incorporate what you have to know this time. I would like, this is an Algebra 1 skill, so it might feel like I'm putting your feet to the fire a little bit, but really as a teacher, my job is to make sure that you're able to follow the material that we're doing. All of the teachers here do that. So going faster or slower is boring, faster is too frustrating. It doesn't make any sense to go other than the pace that we can go. There's a concept that I want you to know, and I might have brought it up last semester, I'm not 100% sure.
Negative. Hangman?
What do you call a function that passes? So this one failed both horizontal and vertical. It failed both. It's both not a function, and its inverse is not a function. What do you call a function that passes both the vertical line test and the horizontal line test? The special term for that? Hangman, go.
It
A.
has an A in it, obviously.
Go back. A.
Obviously it has an
I.
Oh, you can't guess two in a row.
What?
It's not gonna be an I.
E.
You can't get Kira.
I
No.
didn't go twice.
Carlo guessed the A.
Three.
Huh?
Carlo guessed the A.
No. Okay, but let somebody else play. Eric, you go.
Please.
They play if I make them.
I
Yeah, and then it's
can
not
I
for anybody.
I have a guess.
Yes.
R.
No.
What
Right
are
now,
you
they're
guessing?
so bad.
We're guessing a word playing hangman.
Can we
We're guessing the term for a function that passes both the vertical line test, horizontal line test, and
P.
God.
Can I airplane? E.
R.
C.
Sydney.
A-A-R-P.
Amelia, go.
B.
Are these two separate words? Oh.
S.
The. Oh. Oh.
The B.
Oh.
my gosh.
The
Oh.
Who said O?
One.
Who's-
Oh.
one.
Amelia said O.
1.
To one. G. 1 to 1.
What is one?
So it is 1 to 1.
1 versus 1.
Something that if you didn't do the homework, you would not know.
You guys.
What is 1 to 1? What is a 1 to 1 function?
The one that passes both the
Passes
horizontal
all the
and vertical.
tests.
It's a function where one input leads to one output.
Smart function.
Ooh. One input. This is, you could think of this as like the 1 to 1 is an abbreviation for this definition. One input.
Mr. Shale, is your YouTube channel public?
Unfortunately, yes, it is. People have told me it's hard to like get notifications or subscribe or whatever if I don't put it public. So I'd rather have it linked only, but that's what it is now. So one input results in only one output, but the reverse is also true. So this is an invertible function. So what this means for exponents is here's like how it works out for exponents. So for any a greater than 0 and not equal to 1, Okay, so I'm just saying a is greater than 0 and a is not equal to 1, just so the math works out. But other than negative numbers, and you also can't equal to 1, a to the x equals a to the y if and only if, what am I,
The bases are equal.
the bases are equal.
And
But-
then the exponent is equal.
Okay, so what's the end of the sentence? A to the x equals a to the y if and only if.
Oh, the exponents are equal? The same.
So what do I write?
If A is the same. What do you, if
A is by
y,
definition the same. A is not 1, and A
if
is not
X
negative.
equals y? No, but that's not.
We should write it. X
Yes.
equals Y.
Yes. So for this equality to be true, and I have the same basis because I'm using A as an arbitrary real number that's not negative and it's not 1. Why can't it be 1?
Because then it's just
Because 1 sucks.
1 squared. Anything, 1 to the anything is 1.
1 to the 2 is the same as 1 to the 3. So this if and only if is not true if A is equal to 1. That's why it can't be negative. It can't be 1. So if I have 2 to the x equals 2 to the 8.5, and I say solve for x,
This was actually, I really liked it.
what's x?
8.5,
By what principle?
the 1-to-1 ratio function.
1 to 1? Okay.
Chapel. Okay.
Yeah.
We'll get them next time.
That was mean, sorry.
It's okay. Everyone's an asshole.
Hey, thanks. That was just for
Sam, I don't want to do like all that much editing on this video to send it to your classmate.
I don't think my
Kamaya has heard so much worse.
Did
I
you
don't-
say the F bomb in class?
Okay.
Why is the
All right.
death on press several times?
What is that?
So my reasoning here for step 1, that's the original equation.
Wait, are we doing like,
What's my next step?
No, please do not.
How can
make
I
us
use-
proofs.
How can I use this newfound technique based on this example? What can I do to this equation to cure it?
You can make your bases equal.
Right, the base,
Multiplying by
for this principle to work, my bases need to be the same. So how can I express these two things in the same base?
multiply by 3.
Multiply both sides by 3.
Divide by 3.
Divide by 3.
3 squared.
Oh, 3
wait.
squared. I want the bases to be the same. And my reasoning here is just because 9 equals 3 squared.
I didn't do it this way. I just did 2 equals.
What's my next step? We're kind of already there.
You just-
Annabelle.
Just do 2 equals x plus 1 and then subtract the 1 on both sides. And then
2 equals x plus 1 by what principle?
I don't know, but I
1 to
remember.
1.
Yeah,
That's 1 to 1.
I just did it like it is because I thought it was easier. I didn't even square my bases. I literally just took this and took that and did that.
And then what's the answer?
1. X equals 1.
So the 1-to-1 is a property.
Yeah, the one to one property.
I wouldn't have to write next to it 1 to 1 property.
And you have to write your reasons.
Are we really gonna have to do?
Kira.
It's
Kira.
chemistry, geometry.
I'm not like a toddler. You could just tell me to shut up and I'd be nicer than shushing me.
Is it nicer?
Yes.
Yes.
All right, let's do this one.
Shut up, Kira.
Thank you.
All right, you do this one.
Now we're gonna have to edit them.
Oh my god. We'll do this one together. Actually, this This is not that easy.
Wait, I think I can do this one. Just saying.
All right, what's the next step?
Okay. On both sides, because you have to get your bases the same,
Yeah.
you could times both sides.
It's not really multiplying both sides. It's not really dividing both sides. Sydney,
Yeah.
what I'm trying to get to is I'm going to try to get these expressed in the same base. What's an easy way to get these both expressed in the same base? Easy peasy. Straightforward way.
Not when there's a fraction.
What do we know about expressing fractions that makes them super easy and manageable?
That's a what? What?
What do we know about expressing fractions in exponents that make them super easy and
Just
manageable?
put them on the bottom.
Oh,
So you could do, like, would it be 1/8? 1/2 to the 8th?
no, x is my exponent.
Oh, okay, 1/2 to the x equals 8.
What goes here if I am moving it to the denominator?
Negative x.
Right.
Oh, yeah, negative.
But that's actually the opposite of what I want to do. I'd rather just say 2 to the minus x
And then equals 8.
equals 2 to the same base,
Cube.
2 cubed, and that's because 1/1/2 to the x equals 2 to the minus x, and 2 to the 3
Negative
equals
x
8.
equals 3.
And then same procedure. What's next?
Just like the exponents to each other.
Right?
So you get x equals -3.
And what's the reason for that?
Because you divide by negative.
What's my reasoning?
Because you have to divide the negative by a
1 to
negative
1 property.
1, 2, 1 property.
3,
And
2, 1.
Sam, x equals -3. And then the very last step, but you can just call it's all for x.